All right, today is the last day that we're looking at 8.4. We are looking at 8.4 inverse trig. So I'm going to start by introducing this using information that we already have talked about, which is the actual trig functions. So some things that we need to remember. Like I said, I'm going to bring this up almost every day. When we're talking about trig, we're talking about three things, right? And there's a mnemonic device that if you don't know already, you need to. So it is SOHCAHTOA. The SOH, S-O-H, deals with the sine function, right? It is spelled S-I-N-E. But most of the time when we use it, we use S-I-N, but we still call it sine. So SOH is the sine of some angle. I use theta. Is the opposite over the hypotenuse, right? C is for cosine. This is the cosine of some angle is the adjacent over the hypotenuse. And then T is for tangent. And the tangent is the opposite over the adjacent. Right? So again, this is the sine of some angle is the opposite over the hypotenuse. So a few that we've looked at already, and we should kind of know. I don't expect you to have them memorized, but you should know them relatively well. So when I ask you something like the sine of 30 degrees, you should recognize that to be 1/2, right? Or if I ask you for the cosine of 60, that's the cosine of 60 degrees is also 1/2. A reminder on why that is. Right? We have our 30, 60, 90 triangle. The simplest way we can write this, the side opposite the 30-degree angle over here is our smallest side. We'll call it 1. The hypotenuse across from the 90-degree angle is twice as big. And to go from the short side to the long leg, you multiply by √3, so we get √3. So the sine of 30, sine is the opposite over the hypotenuse, that's 1/2, or the cosine is of 60 is the adjacent over the hypotenuse, which is 1/2, right? What if we wanted the tangent of 60? Well, the tangent of 60 is the opposite over the adjacent, right? Tangent is opposite over adjacent. Opposite is √3 over the adjacent is 1. And anything over 1 is just the number itself, right? What if we wanted the tangent of 45? Again, this is one that's not very hard to remember. Tangent of 45 is 1. So if like on the 30, 60, 90, we just make those sides 1. Hypotenuse is √2 times that. Tangent of either of the 45-degree angles is 1/1, which is 1, right? If we wanted the sine of 45, this would be the opposite over the hypotenuse, 1 over the square root of 2. And remember when we spent all that time simplifying radicals, we get √2/2. The cosine of 45 would be the same. purpose of that was not just for review, though it does serve that purpose. The point is that if the sine of 30 is 1/2, right, there should be a way to take the ratio of the side 1/2 and get back to 30. Okay, so if we could compare the sides, anytime that there are sides of 1 and a hypotenuse of 2 in a right triangle, right, the angle that's opposite the 1 should be 30, and the angle that is adjacent to the 1 should be 60, right? So how we do this is something called inverse trig. All right, so instead of taking the sine of some angle, we take the inverse of the sine of some ratio to get the angle. So in other words, we have the sine inverse of the opposite over hypotenuse is the measure of the angle. The cosine inverse of the adjacent over the hypotenuse is the angle. And if you can guess it, the tangent inverse of the opposite over the adjacent, sorry about that, is the angle. In other words, with what we already have above, the sine inverse of 1/2 is 30. The cosine inverse of root 2 over 2 is, or the cosine of 45 is root 2 over 2 is 45. And the tangent inverse of, we can use 1 or root 3, I guess we have both, of 1 is 45. All right, this doesn't just work in these 45, 45, 90s. They work all the time. You will see the sine inverse written as sine inverse itself. So either sine inverse of some number, or you'll see it written this way, which is sine raised to like a negative first power, but it's not actually a power, it's just giving us our inverse. And then you'll see it a third way, not in our book, but in the future possibly, as arc sine, arc cosine, and arc tangent. What you want to think of when we say inverse, you're thinking of just the opposite function, right? So we've dealt with inverse functions before. We have multiplication and division are inverse functions of each other. Addition and subtraction are inverse functions of each other. So these are not, like, the concept of inverse is not new for us. They undo what the other one did. So one cool example, though, this won't show up in your book at all. I just think that it's important to kind of see. If we had the sine inverse of the sine of 30, it is 30. Or if we had the cosine of the cosine inverse of 45, that's bad, of root 2 over 2, we get root 2 over 2. So all I'm showing here is, again, that they are undoing each other, right? The sine of 30 gets you 1/2. Sine of 30 gets you 1/2. And then the sine inverse of 1/2 gets you back to 30. Okay, The examples that you're actually going to be working with will look more like this. So you'll have your right triangle, sides of 5 and 9. And say that we wanted to solve for the measure of this angle, right? So that's the other thing here. The sine, cosine, and tangent functions themselves help you find sides. The sine inverse will help you find angles. So, or the inverse functions, the inverse trig functions will help you find angles. So we have x here, 5 is the side opposite, 9 is the side, that's the hypotenuse. So which trig function do we use with opposite and hypotenuse? It is the sine. We're looking at the sine inverse. So notice that opposite SOHCAHTOA still works with our inverse functions. So we have the sine inverse of 5/9. Now, if you're just using like the Google calculator, I don't know that it has sine inverse. It might. I know that Desmos does. If you're using a calculator like mine, what you do is you press second sine, gives you the sine inverse. So sine inverse of 5/9, and we get about 33.7. Right? What if I also wanted to find this angle down here? Right? Now I have the adjacent and the hypotenuse, right? So I could do the cosine inverse of the adjacent over the hypotenuse. Cosine inverse of 5/9 is about 56.3. Now, what you may or may not notice, 33.7 plus 56.3 is 90. These two angles had to sum to 90, and so it does make sense, right? 90 plus 90 is 180. So we could have just used subtraction here, right? 90 minus 33.7 would have given us 56.3. All right, I want you to find the third side now. So pause the video, find the third side. That's this side up here. We'll call it Z. All right, so hopefully you did. 5 squared plus Z squared is 9 squared. You get 25 plus Z squared is 81. 81 minus 25 is 56. Take the square root of both sides and we get the square root of 56. If you simplified it, you would get 2 root 14. All right, let's take a look at one more. So I don't care which side you find first, or which angle you find first. You can find the side, you can find the angle. Let's do x. So we have x, 10 is the adjacent, 14 is the hypotenuse. So that is a cosine, right? Adjacent and hypotenuse go with the cosine of 10 over 14. If you wanted to call it 5/7, you could do that as well. Sorry, we forgot the inverse, right? So we have the cosine inverse of the ratio of the sides for the cosine is equal to x. All right? And if we do the cosine inverse, 10 over 14, we get about 44.4. Now we're going to find y the easier way. Y is equal to 90 minus x, or about 90 minus 44.4, which is about 45.6. And then lastly, finding z. 10 squared plus z squared is 14. 14 squared. So we get z squared is 96. And if we take the square root of both sides, and simplify, if you don't simplify, you'll get the square root of 96. If you do simplify, you get 4 root 6. Sorry, you get 4 root 6. All right. Homework assignment will be posted, so you just need to check it out on Canvas.